All right, so get ready because today we're diving into a paper that asks, a pretty unsettling question.
Yeah.
What if most research findings we see, like the ones that get published,
Right.
are actually,
Right. False.
like, completely false?
Yeah, it's a bold claim, for sure.
It is.
It comes from a researcher named John Ioannidis.
Okay.
And he really kind of dug into I guess the cracks in the foundation of scientific research
Mm-hmm.
in an essay he wrote called Why Most Published Research Findings Are False.
Okay, so we've all seen these headlines, I'm sure, right?
Oh,
Like,
yeah.
coffee cures cancer,
Right.
chocolate is the fountain of youth.
Yeah, yeah.
And then, a few months later, there's another study that says the exact opposite.
Right.
So how are we even supposed to make sense of all of this conflicting information?
Yeah, and that's really the heart of the issue here.
Okay.
This constant flip-flopping of findings erodes trust in science.
Right.
And Ioannidis argues it's not just random chance or sloppy research.
Yeah.
He says there are actually systemic factors kind of bake into the process that make these false positives way more likely than we might want to admit.
Okay, so before we go any further, I think we need to break this down a little bit.
Yeah.
For those of us who maybe aren't scientists,
Sure.
what exactly is a false positive when we're talking about research?
Okay, think of it like this.
Okay.
You flip a coin 10 times and you get heads 8 times.
Okay.
You might conclude that the coin's biased, right?
Right, yeah.
But it's possible you just got lucky
Mm-hmm.
with a perfectly normal coin.
Right.
That's a false positive.
Okay.
You're getting a result that suggests something is true
Yeah,
when it actually isn't.
I see.
So in research, it's when a study shows a statistically significant result
Yeah.
that doesn't actually reflect a real effect.
Okay, so just because a study says there's a link between, I don't know, let's say eating pineapple and being like a tech genius or something,
Right.
that doesn't mean it's actually true.
Exactly.
Oh.
A single study's results, especially if it's a small study or not well designed,
Yeah.
should always be taken with a grain of salt.
Okay.
And so Ioannidis, in this essay, he digs deep into why these false positives are so prevalent.
Okay.
And he outlines several factors that can make research less reliable.
Okay, let's unpack those factors.
Yeah.
What are some of the things that can make research, I guess, kind of skew the findings?
Well, one key factor is the size of the study.
Okay.
Smaller studies have less statistical power,
Okay.
meaning they're more likely to produce those false positives we talked about.
Uh-huh.
So to put it simply, if you want to see if a coin is biased, flipping it 10 times won't give you as much confidence as flipping it 1,000 times.
Right.
You see what I mean?
Okay, so size matters in research.
Absolutely.
Larger studies tend to be more reliable. What else should we be watching out for?
Well, the size of the effect being studied,
Yeah.
that also plays a role.
Uh-huh.
So research areas with large, very obvious effects, like the impact of smoking on lung cancer, for instance,
Right.
they tend to have more reliable results
Yeah.
compared to studies looking at smaller, more subtle effects,
Okay.
like maybe the link between a specific gene and a very complex disease.
Oh, okay, so it's kind of like
Yeah.
finding this massive game-changing effect
Right.
is more likely to be true than finding this tiny little
Exactly.
barely there effect.
It's a good way to put it.
But I'm guessing it's not quite that simple, right?
You're right. There are definitely nuances to consider.
Okay.
For example, is the research trying to generate a new hypothesis or confirm an existing one? That can make a really big difference.
That's interesting. Can you elaborate on that a little?
Yeah, sure.
Yeah.
So imagine you have this hunch that people who wear red shoes are better drivers,
Okay.
and you design a small study to see if there's any evidence for this.
Uh-huh.
This is called hypothesis-generating research,
Okay.
and it's much more prone to false positives. Now, if somebody wants to confirm your red shoe theory,
Right.
they'd have to conduct a much larger, more rigorous study.
Yeah.
Maybe even what we call a meta-analysis,
Okay.
which is where they combine data from multiple studies.
Got it.
And this confirmatory research is less likely to be swayed just by chance.
Okay, that makes sense.
Yeah.
Now, I was reading the essay, and Ioannidis also talks about how flexibility in a research design
Yeah.
can actually make a study less reliable,
Right.
which kind of seems counterintuitive.
It does seem that way. Flexibility is great in many aspects of life.
Sure.
But in research, too much flexibility can lead to bias.
Okay.
So if researchers have a lot of leeway to, tweak their methods or definitions, or even their data analysis after the study's already started,
Right.
it can unintentionally or sometimes intentionally
Yeah.
push the results towards a desired outcome.
It's like moving the goalposts during a game.
Exactly.
Yeah.
And that can seriously distort the findings. It's like trying to hit a bullseye when the target keeps shifting around.
Yeah, that makes sense.
So Ioannidis also brings up the influence of financial interests and even prejudices.
Oh, yeah. The age-old follow the money.
Yeah, but it's not just about financial motives.
Okay.
Scientists, even with the best intentions,
Right.
can be biased towards their own theories, especially if they've invested, years of their life in them.
Right. Sunk cost fallacy.
Exactly. And this can influence how they design their studies,
Yeah.
collect their data, interpret the results.
Okay, so even without, big pharma lurking in the shadows or something,
Right.
research can still be affected just by the researcher's own biases.
Absolutely.
Wow.
And this leads to a fascinating paradox that Ioannidis points out.
Okay.
The hotter a research area is, meaning the more popular and competitive it is, the less likely the findings are to be true.
Oh, wow. Okay. So
Yeah.
I would think that more people working on a problem would lead to more accurate findings, right?
You would think so. But in these hot fields, there's so much pressure to publish these groundbreaking results
Yeah.
that it can lead to researchers cherry-picking positive findings
Oh, I see.
and ignoring negative ones.
Got it.
It's like trying to win a race where everyone's cutting corners.
Okay.
And Ioannidis calls this the Proteus phenomenon.
There's a Proteus phenomenon.
Where research claims in these fields are constantly changing and being refuted.
My head is spinning a bit.
Yeah, it's a lot.
So how bad is this problem, really?
Yeah.
Does Ioannidis, actually quantify this idea that most research is false?
He does, yeah.
Okay.
He actually uses simulations and statistical models
Okay.
to estimate the probability of a research finding being true
Okay.
under different circumstances.
So like a scientific crystal ball
I like that.
that can predict
Yeah.
the reliability of a study.
Not quite a crystal ball, but more like a very sophisticated calculator. These simulations, they take into account things like study size, bias, the number of other studies on the same topic, all that kind of stuff, to estimate the likelihood that a finding is actually true.
Okay, I'm following. So what do these simulations actually show? What's the verdict?
Well, the results are, frankly, a bit unsettling.
Okay.
He found that in many cases, the probability of a research finding being true is surprisingly low. For example, an underpowered early-phase clinical trial,
Yeah.
the kind that often gets a lot of hype in the news and stuff,
Right.
might only have around a 23% chance of actually being true.
23%. So that's barely better than a coin toss.
Exactly.
Okay.
And it really highlights the importance of looking beyond just the headlines.
Right.
And then in exploratory research, where there's this massive testing going on,
Yeah.
like researchers are looking for a tiny signal in a sea of data.
Yeah.
The probability of a finding being true could be as low as 0.1%.
0.1%.
Yeah,
Right.
practically zero.
So how are we supposed to make sense of any research if the odds are completely stacked against it?
That's a good question.
Yeah.
And that's precisely why this work by Ioannidis is so important.
Okay.
It forces us to really rethink how we evaluate scientific information
Yeah.
and understand the factors that can lead us astray.
Okay.
But, it's not all doom and gloom.
Okay.
He also offers some strategies for improving the situation.
Okay, so we've established that the problem is real
Yeah.
and it's probably bigger than we imagined.
Yeah.
But what can we do about it? Are we doomed to just drown in a sea of unreliable research?
Not at all.
Okay.
Ioannidis outlined some really practical ways to improve the reliability of research.
Okay.
And it's not just up to the scientists.
Mm-hmm.
You, the reader, actually play a crucial role as well.
Okay.
It's about becoming a more informed consumer of scientific information.
Okay. All right. I'm ready to learn how to be a scientific detective. So what are some of the things that we can do to be more, discerning consumers of this research?
Well, one of the most important things is to look beyond just the p-value.
Okay.
While statistical significance is important, it doesn't tell the whole story.
Okay.
We really need to focus on something called the positive predictive value, or PPV.
PPV. I've never heard of that.
Yeah, it's kind of a mouthful,
Yeah.
but it's a really important concept.
Okay. So what is it and why is it important?
Well, PPV tells us the probability that a positive research finding is actually true. It goes beyond statistical significance.
Okay.
And it takes into account the prevalence of false positives in a particular field. So you're kind of putting it into context.
So how do we actually use this PPV when we're like reading a research paper?
Well, Ioannidis, he actually lays it all out in Table 4 of his paper,
Okay.
which lists PPVs for different types of research
Okay.
based on things like study power, bias, the pre-existing evidence, all that. And you can use this table as a guide to get a sense of how likely it is that a particular finding is actually true.
This table sounds really cool.
It is?
Can you give us an example of how this works?
Yeah, sure.
Let's say I'm reading a study about a new treatment for,
Okay.
I don't know, back pain or something.
Okay.
How could I use this table to kind of evaluate its credibility?
So let's say this back pain study that you're reading.
Yeah.
It's a small, early phase clinical trial
Okay.
with a relatively small effect size.
Okay.
You could look at Table 4, and you might find that for that type of research, the PPV is only 15%,
Oh.
which means there's a high chance that the, seemingly promising results of that study
Yeah.
might not hold up in larger, more rigorous trials.
15%. Wow. Okay. That's a big reality check.
It is.
Because the study itself, it's claiming statistically significant results.
Right. But the PPV is saying,
But the PPV is saying,
Yeah.
hold on a second.
pump the brakes.
Yeah, this might not be what it seems.
Exactly. The PPV helps us put those findings into perspective
Right, yeah.
and understand the likelihood that they're really reflecting a real effect.
Okay, so PPV
Yeah.
is an important tool
Absolutely.
for understanding the reliability of a study.
Yeah. One of Ioannidis' most thought-provoking arguments is that in fields with like a low probability of true findings,
Yeah.
any observed effect might just be reflecting the underlying biases
Uh-huh.
of the research itself.
So it's kind of mind-bending.
Yeah, it's kind of mind-bending. Yeah.
Yeah.
It's like we're trained to think that these big, exciting results,
Right.
those are the breakthroughs, right?
Right.
But Ioannidis is kind of suggesting that in some cases, those flashy findings
Yeah.
could actually be red flags.
A big red flag.
Yeah.
Take genetic research, for example. We know that thousands of genes are being tested for links to various diseases.
Yeah.
But the reality is, most of these genes probably have very little to do with the disease.
So even if a study finds a link between a specific gene and a disease,
Yeah.
it doesn't necessarily mean anything.
Right. It could just be a false positive.
Okay.
Maybe a fluke of the data. Okay, so how do we avoid falling into that trap then?
Well, Ioannidis argues that instead of getting caught up in chasing statistical significance, we need to shift our focus to understanding the pre-study odds.
Pre-study odds. What does that mean?
It's basically asking, before we even do a study,
Uh-huh.
how likely is it that the thing we're testing is actually true?
Okay.
So, for instance, if we're testing a new drug for like a deadly disease,
All right.
and we already have a lot of evidence that suggests the drug works,
Okay.
the pre-study odds are pretty high.
Mm-hmm.
So a positive finding in that case
Yeah.
would be much more believable
I see.
because there's already a strong foundation of evidence.
So the groundwork's already been laid.
Exactly.
Okay.
But in a field where the pre-study odds are very low,
Yeah.
like let's say trying to find a genetic link to something as complex as personality,
Right.
we should be much more cautious about interpreting those positive findings because there's a much higher chance that that finding could just be a false positive.
This is really interesting. It's like,
It's a whole different way of thinking about it.
yeah, it's like looking at research through a whole new lens.
Yeah.
Instead of asking, is this statistically significant?
Right.
We should be asking, how plausible is this in the first place?
That's a great way to put it.
Yeah.
It really emphasizes the importance of critical thinking
Yeah.
when it comes to scientific information.
Mm-hmm.
We can't just accept everything we read at face value.
Right.
We really need to ask questions, consider the context,
Yeah.
and be very aware of the potential for bias.
Ioannidis even says that entire fields of research might be built on false findings.
It's a bold statement.
That's a big one.
He uses the example of this hypothetical field where researchers have studied 60 different nutrients,
Okay.
and they're claiming that all of them are linked to the risk of a particular tumor.
So every nutrient you can think of is related to this tumor.
Yeah, like from vitamin A to zinc. That seems,
A little far-fetched.
yeah, a little far-fetched. Yeah.
And Ioannidis argues that in a case like that, the claimed effects might not be real at all.
Okay.
They could simply be a reflection of the biases
Uh-huh.
operating in that field of research.
So instead of discovering actual relationships, they're just kind of finding what they're predisposed to find.
Exactly. And this brings us to another really interesting point.
Okay.
Ioannidis suggests that in fields with these very low probabilities of true findings,
Mm-hmm.
the studies that report the strongest effects
Okay.
might actually be the ones with the most bias.
Wait, hold on. That seems counterintuitive.
It does, yeah.
Because I would think strong effects would be,
More likely to be real.
yeah,
You would think so, but remember, in a field where most findings are likely false,
right.
the studies with the most dramatic results
Yeah.
might simply be the ones that have been manipulated or cherry-picked
Okay.
to make the findings seem more impressive.
I see. So how do we protect ourselves from being misled then? Well, Ioannidis proposes several strategies,
Okay.
both on the research side and for us as consumers of information.
Give us the rundown.
All right, so from the research perspective,
Yeah.
it starts with focusing on well-powered studies
Okay.
with rigorous designs.
Uh-huh.
Large, well-designed studies are much less likely to be swayed by random fluctuations or biases.
So bigger is better, as we discussed earlier.
Pretty much.
Okay, what else can researchers do?
Another really important step is to minimize bias throughout the entire research process.
Okay.
This means using clear definitions,
Yeah.
standardized methods, being transparent about any potential conflicts of interest.
Right.
Basically raising the bar for scientific rigor across the board.
Makes sense.
Yeah.
But even if researchers do everything right,
Yeah.
there's still the challenge of us interpreting those findings.
Right.
So how do we as readers avoid being fooled?
It comes back to being an active and critical reader.
Okay.
Don't just accept things at face value. Remember to consider those pre-study odds.
Yeah.
How likely was this claim to be true before the study was even conducted?
Right.
If the pre-study odds were low,
Yeah.
you want to be extra cautious about accepting the findings
Okay.
without further investigation.
So instead of just absorbing information passively,
Right.
we need to engage with it.
Be an active participant.
Yeah. What other strategies can we use?
Don't get swept away by a single study,
Okay.
no matter how impressive the results might seem.
Yeah.
You want to look for consistent patterns across multiple studies.
Right.
One study claiming that drinking grape juice improves your singing voice might be interesting.
Okay.
But if 10 other studies show no such effect,
Uh-huh.
it's probably safe to assume that initial study was a fluke.
So look at the bigger picture.
Exactly.
Don't jump to conclusions just from one study.
Right. And finally, never forget that bias can creep into even the most well-conducted research.
Yeah.
No study is perfect.
Right.
Researchers are human,
They are.
and they have their own perspectives and potential biases that can influence their work.
Right.
So don't treat scientists as these infallible authorities.
Okay.
Approach their findings with a healthy dose of skepticism
Okay.
and an open mind.
That's an important reminder.
Yeah,
Scientists are just people trying to figure things out,
that's right.
like the rest of us.
Exactly. By understanding the limitations of research
Uh-huh.
and approaching scientific information with a critical eye,
Yeah.
we can become more informed and empowered consumers of knowledge.
I love that. That's really good. Okay, so
Yeah.
this has been really eye-opening. It's like my scientific literacy has just gotten a major upgrade.
Awesome.
Anything else you want to highlight before we move on?
I think the key takeaway here is that we really need to change the way we think about scientific research.
Okay.
Instead of viewing it as this source of absolute truth,
Yeah.
we should see it as a constantly evolving process of discovery,
Okay.
where uncertainty and debate are not only inevitable,
Yeah.
but essential.
That's a really good point. It's
Yeah.
not about finding all the answers. It's about asking the right questions
Absolutely.
and, being open to new evidence
Right.
and constantly refining our understanding.
Exactly. And that process of refinement
Yeah.
often involves challenging established beliefs
Uh-huh.
and overturning previously held truths.
Right.
That's how science progresses.
So considering those pre-study odds,
Yeah.
looking at all of the evidence, not just one study,
The big picture.
the big picture, exactly.
Yeah.
And really thinking critically about what we're reading.
Thinking for yourself.
Yeah, exactly. So let's bring it all home.
Okay.
How can we actually apply these insights to our everyday lives?
Yeah, that's the big question.
Yeah, how can we navigate this sea of research and
Right.
make informed decisions?
It is a lot to wade through.
It is.
Yeah.
It is. So let's get practical.
Okay.
What are some concrete tools
Yeah.
that we can use?
Well, one of the most important things is to cultivate a healthy sense of skepticism.
Oh, okay.
So don't just blindly accept everything you read,
Right.
especially if it's based on a single study or it comes from a source that's known to be biased.
So, like, channel our internet sleuths,
Yeah.
fact check. That's
Exactly.
cool.
Be critical.
Yeah.
Ask yourself some key questions,
Okay.
like who conducted the research?
Yeah.
What was the study design?
Uh-huh.
Are there any other studies that support these findings?
Okay.
Dig a little deeper.
Yeah, don't just take it at face value.
Exactly.
Okay, so channel our inner skeptic.
Uh-huh.
What else?
It's also crucial to be aware of your own biases.
Okay.
We all have preconceived notions and beliefs
Yeah.
that can color how we interpret information.
So, if I already think that, like, sugar is the root of all evil,
Right.
then I'm probably going to be more likely to believe a study that says that,
Exactly.
even if it's flawed.
Right. It's human nature to gravitate towards information that confirms our existing beliefs.
Yeah, it's comforting,
It is.
but we have to try to be open,
We do.
Yeah.
Be open-minded and be willing to consider different perspectives.
even if they challenge what we think.
Exactly. Even if it makes you a little uncomfortable.
Yeah, that's tough.
It is tough, but it's crucial for intellectual honesty.
I like that. That's good.
Okay, so let's get into some specific strategies
Okay.
for evaluating research findings.
All right.
Remember that p-value we talked about?
The one that tells us if it's statistically significant.
Yeah, exactly.
Yeah.
It's a valuable tool,
Okay.
but it's important to remember that the p-value doesn't tell the whole story.
Okay.
It doesn't tell us the magnitude of the effect
Right.
or its real-world significance.
So a study might show a link between, like, I don't know, eating broccoli and living longer,
Yeah,
but the effect could be so small that it doesn't even matter.
exactly.
Yeah.
Always consider the size of the effect.
Okay.
Is it a minor blip or is it a major game changer?
Right.
Don't get too excited about a tiny effect that's been blown out of proportion.
Right. So p-value,
Yeah.
effect size.
Mm.
What else?
Pay close attention to the study design. Was it a randomized controlled trial,
Yeah.
which is like the gold standard for cause and effect?
Right. Yeah.
Or was it an observational study,
Okay.
which can be helpful, but it doesn't actually prove causation,
Right.
just association?
Okay. So if I'm reading about some new weight loss supplement,
Right.
I should be more skeptical if it's just an observational study.
Yeah, observational studies can show correlations,
Right.
but they can't definitively say that one thing caused another.
Okay.
For that, you need a randomized controlled trial.
Got it. So consider the study design, look at the effect size. Don't just get hung up on the p-value.
Right.
What other red flags?
Don't forget to check the funding source.
Oh, right.
Any potential conflicts of interest.
Okay.
If a study was funded by a company that stands to profit from the results,
Yeah.
be a little cautious.
Follow the money.
Exactly.
Okay, so we've learned a lot today.
We have.
Any final words of wisdom?
Yeah, I think the biggest takeaway is that science is a process, not a
Mhm.
destination. It's this continuous journey of questioning and testing and refining our understanding of how the world works.
I love that.
So don't be afraid to challenge assumptions, dig a little deeper.
Yeah.
Think critically about the information you encounter.
Awesome.
Yeah.
Well said.